I'm going to talk about the Gno VM, and hopefully by the end of this talk, I change our perspective on what, how smart contracts can be composable, right? Because we've been talking a lot about composability of smart contracts, and I'm going to try to convince you that there's a lot of complexity around composability that are introduced because of the limitations of our virtual machines, and and things that are sort of difficult to solve, but that the Gno VM solves. So I'll go over some basic points first. The Gno VM is a virtual machine, like WASM is a virtual machine, or the JVM is a virtual machine, but it's built from scratch. It's designed to interpret Go AST, so the abstract syntax tree of Go itself, it interprets. It's a stack-based machine, and it's written in Go, so everything is pure Go, and it interprets Go. One of the main differences when programming in Gno, which is the language, it's basically Go 1.17 minus generics, is that at the end of a transaction, the things that are in memory automatically get persisted because the virtual machine is able to know what in-memory objects you have created or modified. And I'll get more into it later. Another thing that the Gno VM does is it has granular gas counting. So think of Ethereum gas counting for CPU and storage. It basically has that. It's very granular and allows you to do magic. And I'll show you more. I think the big thing to take away from this is considering the usage of import statements. So what I mean is, we've been discussing the composability of smart contracts with CosmWASM based on the actor model. So composability is generally, we're talking about having independent modules that are connected by passing messages between each other. So what if we rethink that and build something else instead? What if we can actually just use the language itself as the composability glue? And I'll show you what that means. I know it sounds kind of crazy, but you'll see. So you can't do this with the Cosmos SDK. This is completely different than programming in the SDK, and you'll see that. And you can't really do this in WASM either without some ridiculous LLVM surgery, or I don't even know how you would do it. In short, the Gno VM is going to be, or is, the ultimate smart contract platform. Next slide, please. Okay. So this is not a real contract, but it kind of demonstrates, and I'll point at things here so you understand what I'm talking about. All right. So in the CosmWASM, we have modules which are independent smart contracts, more or less, right? In Gno, you have smart contracts too, but they're all just code you can import. So here's what I mean. This, for example, is Bob's smart contract called reputation. So in order to use it, you don't have to create a lot of boilerplate about message types. You just import it. And here's another smart contract. The difference between P and R is that P stands for pure or persistent or permanent. It's got no states and immutable, so it's a pure package. R we call it a realm. Basically, it's a package just like a Go package. It looks just like a Go package, but it's got global state that you can modify. So all the states in Gno.land or Gno are stored in realm packages. So reputation is stateful, sanitize is just some library, and AST is also some library. Well, it should be AVL. I keep doing that. And also we have some standard libraries too, like you can use errors and other things. Okay, so this itself is Alice's smart contract that handles events, right? So you see here that there's a global variable called events. This is a tree. It should be AVL tree. I always do this. I don't know why. Here's a function called by ticket. So this is capital B. So we're just using language features here. So if you understand Go, you know that it means it's exposed. So if you have an exposed function, it means it's a function that's callable by anyone from the any user of the chain. And STD standard, you can get the caller of the function. It just looks like Go, right? But of course, this is not Go. You can't actually do this. You can program the whole thing in Go, but then it would just be in-memory stuff, and the state would not be persisted, right? Okay, can you scroll down a little bit, please? Yeah, so in short, a realm is basically a smart contract DApp, and pure packages, Gno.land/P, these are more libraries. And also, in order for realms to communicate with each other, you do need types of messages. You can declare them in P types and know that they will always be there. All right, I'll show more examples, so don't worry too much about understanding this stuff. But I do want to say that, let's move on. Okay, so here's something more concrete. So comparing GNO contracts with CosmWASM programming. So let's say you have this. This is basically a pretty simple Go code or GNO code. And I'm going to show what it's like to translate this into CosmWASM and see how much more complex it is. Here's it's sort of a misnomer, but the point is this is showing all the balances for a certain type of coin. I think anyone who programs Go can understand what this does, right? Total supply, you're returning a field right here of a structure, just straightforward Go stuff. And in order to burn something, you have an unexposed function that subtracts the amount. So let's see what it takes to kind of replicate this in CosmWASM. So scroll down a bit, please, to the next contract. Yeah, so first you need to have some sort of what is this? It's like a message dispatching layer, right? So you have to declare this as a message on some high-level entry point thing. So here you have the register burn from. So you have to do that in one file. Scroll down a little more. Thank you. You register your queries separately, right? Probably in some other different file. Scroll down a little more, please. And to actually decrement the number, as you saw before, which was just a method with a minus equals, you need to use some special state singleton thing. Scroll down a little more, please. Yeah, so this is actually from the CW20 example. So this was declared in another file. So this is what actually stores the state. And then this actually does the state mutation. It's pretty complex, and it's not idiomatic Go or anything. It's kind of split into multiple things, and you have to understand a lot of things, not just Rust in this example, but also how CosmWASM actor model works, and you have to understand the way to modify state. It's a lot like programming in the Cosmos SDK, but with more complexity. But scroll up again. Yeah, I just want to show like all these things are all the way to the top, please. One more right here, yeah. So yeah, this is just one file. And I'll show you another example later, but yeah, let's scroll down to the next set of slides that we haven't seen before. Okay, I'm gonna just talk about now like the current state of, well, I guess before I talk about that, so I just want to recap. Composability is a big deal, and you do want type checking when you compose smart contracts. But the problem with CosmWASM and other smart contract systems is they're generally based on the actor model where you have to pass messages, and that is like a layer of complexity on top of the language itself. If you can just interpret the language using a special virtual machine like the Gno VM, you can compose smart contracts, and it's just handled by the language itself. And you get type checking too, of course, because we're using Go. I can talk more about type checking in a bit. We do have some smart contracts already implemented, GRC20, GRC721, 1155. You can go here to see that. And here, yeah, if you can zoom out a bit to see the whole. Thank you, yeah, and scroll up. Scroll up a little more. Thank you. Yeah, so you can see this is a Go interface. So imagine if all these, ERC20, all these things actually had proper interface definitions just in the language. I mean, that's what we do. This is, of course, just part of the code. The actual implementation is in other files, but you can actually take a look yourself. Let's scroll down to, all right. I'm just going to show some things we've been doing because, the intent is to show the progress of what we've been doing. The Gno VM has been working for a while, but we've actually been building a lot of things on top, so I'm giving you a survey of what's been going on. This was a nice submission for a JSON parser by, I believe, June. So this is, I just want to point out that we're actually using what are, well-known Go standard libraries. You can just import these things like strconv for converting strings and bytes for creating buffers. We actually just copied over the Go code into GNO code, and with minimal modification, or most of the time no modification, it just works. So when you import these things, it's actually running GNO code in the virtual machine. So that kind of gives you a sense of like the completeness of it. So here, you see that it's marshalling a node. This is a little strange. It should be more like an interface that takes anything, but it's a node because we haven't implemented reflection yet in GNO. But as soon as you do that, then you'll be able to marshal any object. But mostly I just wanted to show you what kind of things you can do. You can see that we're actually using a bytes buffer. So all these things are being interpreted into Gno VM. Okay, let's go to the next slide, please. Here's another example. If you go to the GNO repo and issue number or pull request 15648, you can see it, but you can also see it. I can show you later where you can find these things. But this is just creating an oracle with multiple feeds. So again, like you can create an instance, you can add a feed, you can create you can pass in some whitelists. This is all, anyone who understands Go can understand this code. That's the point. It's all just Go code. All right, I'm going to show you something cool that we've been doing. Recently, we added a debugger. So this is just like GDB, if you're familiar with that. So you can actually run this now. It's already available, although there's a slight bug, so it might be a little more difficult. But you can actually run exactly this. GNO run, this is a fib function, and you just pass this debug feature in, and then it'll put you into a debugger. And here we step in, you can see the help. It's basically the standard commands that you're familiar with Delve. Let's scroll down a little more. Set a breakpoint on line 9, continue, and you can see that it works. Adding this was really easy. It only required one line in the machine. Because just the way the machine is written, it's really simple. We don't try to do like too many optimizations. It's intended to serve as a spec and something for people to be able to learn and understand easily. And everything is implemented in a pretty straightforward way. So adding this debugger was a breeze, relatively speaking. This is not as related to GNO, but I want to share something that we've been doing that was really helpful for us that I think will help all the blockchain projects. So in the Go project itself, they have this thing called TxTar that they use for integration testing of Go, I suppose. And there's a fork of it to kind of expose that to other users. And we use this TxTar system test script, right, in order to test our blockchain. So what you're about to see is a single file. Let's scroll down a bit. These are not bash commands. They're actually hooking up directly into the CMD, the CLI function. So it's not actually using bash, but it kind of looks like it. But you can register special commands to do whatever you want. Here we start a node. And here, this is actually calling the same code as the CLI for make.tx, but with some special hooks. So we're actually registering a package, uploading it. Actually, this is calling. Oh yeah, I'll show you what this is in a bit. We're calling a function with this argument or 2 arguments, and then here we are uploading 2 more packages, and we're calling another function. So I'm going to show you what this is about. It's kind of cool. And by the way, just the whole point is this whole thing, the TxTar, this is one file that does multiple things, starting a node and uploading smart contracts and calling them. Even though I broke it up, it's just for syntax highlighting purposes. So it's really nice. I think every blockchain project should use this for testing, integration testing. So what I want to show you here is, let's see, register is, okay. So this is cool. So talking about composability, imagine trying to have one module of a CosmWASM smart contract register a callback to another module. Like, that would be really difficult to do. I mean, I guess you can figure out some way to do it, but it would require a lot of logic. But in Go you can, and so in Gno you can. You see that there's a type for the callback function. It's all type checked, of course. This is an exposed smart contract function, and anyone can register a callback function, right? So you can literally save a closure or a callback function across transaction boundaries. I don't think you can do that anywhere else, anywhere, not even Ethereum, right? But you can in Go. Okay, so I'll show you more of the usage. It'll become more obvious. Let's see. Yeah, so what we did earlier was we called this, oops, it's okay. All right. Yeah, so the registry, this smart contract was uploaded, right? And then later we call, and when we upload this function, in its initialization function, you're familiar with init if you program Go, automatically it registers to this smart contract a function from another smart contract. So this is some crazy composability that you can't do anywhere else, but you can in Gno because we wrote a virtual machine that allows you to do it. Right? And if you scroll down a little more, you'll see that this is just anyways, you see the function. Yeah, okay. This is not a closure, but it's still a function that you were able to register on another smart contract. So super expressive, arbitrary composability. I don't think you can get more expressive than this, and type safe because it's just the language itself. Scroll down a bit. Here's another thing that we're doing. So this is not Gno specific, but if you scroll down up a bit, yeah. If you go here, we have a faucet. I think every blockchain project wants a faucet, so we made one. It's pretty well made, modular faucet project that I think a lot of blockchains will want to use. If you scroll down, this is what it looks like for us right now. There's just it's using a CAPTCHA, right? So pretty simple now, but in the future we'll be extending it to do more things, maybe add credit card support or all kinds of other things. Okay. So our homepage for Gno.land, when you go to Gno.land, it's actually rendering Markdown from a smart contract. So the website of Gno.land is, the homepage itself is also just a smart contract. And you can actually see if you remove the stars, my bad, here. If you go to this file, don't actually go there, please. My bad. But yeah, oops. Oh, I did that. Okay. Yeah, so every smart contract, every dApp has a render function. So you can actually, on the web page, go to Gno.land r username / smart contract name, and what you will see along with the files, so you can navigate to see the files themselves, but it will also call this smart contract render, and it will return a markdown string. You see that we're actually creating a virtual DOM and appending things. The one thing I want to show you especially is here, latest blog posts 4. So the home page is rendered using a smart contract that imports the latest blog post and is dynamically rendering the website. So that's pretty cool. Try doing that in Ethereum. I don't think you can. I'm sure you can, but it'll be complex. So yeah, so this is a section of the web page that's rendered, and you can see there are the latest blog posts. If you go to Gno.land, you can actually see it. All right. A little bit on the license, because earlier there was a claim that it's not even open source. Well, it is open source. What we did was we forked the AGPL because the AFRL GPL is about providing the source code to the user, even if it's through a network, right? I think that makes sense for blockchains. But we changed the GPL just slightly to allow for this strong attribution clause. And what it says is that if you create a web page or a thing, or a blockchain especially, that allows users to upload their own smart contracts, then you have to prominently link to Gno.land, right? So in other words, it's otherwise, you're free to use it. If you're going to use this in a permission sense, where like governance has to approve of the smart contract to upload, you don't even need to worry about the strong attribution clause. Really, we're trying to minimize copycats that try to create their own version that doesn't really add anything and then confuses users. But my point is, if this doesn't work for you, then let us know. So if you're going to create your own blockchain and you feel like this is too restrictive, or maybe the AGPL is too restrictive, let us know, and we can try to work something out. We definitely want many blockchains using the Gno VM. We want Gno.land to be one of the first to launch and become a repository of smart contract code. But anyone is free to even compete with us. We just want attribution, not just in the source code, but actually we want the users to know where it came from. That's the point. And I think a lot of blockchains should use this license with the strong attribution. I think it makes a lot of sense. Oftentimes users have no idea where the source code came from, but this is enforcing the users to know who actually built the system and to give proper attribution besides just in the source. Scroll down a little more, please. There's a lot more I can talk about, so I'll go over these real quick. We're working on IDE. It's a web-based IDE. It's pretty amazing and streamlined, but sorry, I don't have a demo for it, but it's an alpha. Scroll down, please. This is even cooler, I think, or just as cool, because it's working and it's so nice. So the Go playground, you can upload Go code. This allows you to upload Gno code. And when you upload it, what's happening is it's running the Gno VM in WASM on your browser. So you can run the Gno VM on your browser with WASM just through the playground. We also have some DAO software that we've created. Internally, we have this domain called Gno.me, and we want to try dogfooding our own system to run it as a DAO. So this is how the Gno.land website works. Generally speaking, we want users to interact with smart contracts through the markdown rendering of the smart contract. So this was actually, again, rendered from the smart contract itself. And you can see the source code just by going here. So if you click on the website, if you go to Gno.land/r gnome DAO v1 dev1, you'll see this, and then you can go for any smart contract, you'll be able to see the source code itself, which I think is important for transparency. All right, scroll down more, please. So I can talk a lot more, but here's some things that we're working on. We're finalizing some of the opcode benchmarking. I just want to say that we haven't done any optimization, but it runs right now an order of magnitude slower than Python 3, but it'll get faster. If you do a simple for loop or like Fibonacci, you'll see that the average opcode time per opcode on average is like 45 nanoseconds, which isn't too bad. Of course, on the blockchain in the mass user scale setting, in like an Ethereum setting, the bottleneck is probably going to be storage. So I don't think it's going to matter for most applications anyways, but we'll definitely make it faster. And then other implementations, perhaps in Rust, can be even faster than that. We have Gno.mods, there's versioning when you develop. We piggyback on the Go type checker, so it is type safe, but we're also working on our own type checking too, just to make it independent of Go. There's OnBlock has created an amazing wallet called Adena, so check that out. Like I mentioned, we're going to work on the reflection library. We're going to do some refactoring of the AST preprocessor to make it easier to understand and have multiple phases. That's got to do with, I'm not even going to get into that. And then a big piece we still have to do, but it's actually pretty easy, is just implement the synchronous garbage collector. That's actually pretty easy because we're piggybacking on the Go garbage collector. So all we have to do is, at any given snapshot, calculate how much space every object takes that is reachable. And then we'll have a synchronous garbage collector. But even without it, all of these smart contracts are running. So you can go ahead and develop now. I'm just letting you know, when we launch the chain, by the time we launch the chain, later this year, it'll be even better. Oh, okay. So a little bit on Tendermint. We forked Tendermint a while ago, and we're calling it Tendermint 2. It's actually embedded in the Gno repo. A big thing that we did recently was we took out the transaction indexer entirely, and TM2, Tendermint 2, what it does is it logs all of the events into a file system. And we moved the indexer as an external process, so it makes Tendermint 2 more of a lightweight process, right? So I think that's how it should be. It should be minimal. So we did that, but I mean, there's also obviously a lot of good innovation and bug fixes and optimizations that has been happening on Tendermint. So we'll be integrating those as well over time. There's also a small project. It's called TM Lite. Or it's going to be called TM Lite. It's a very simple BFT algorithm, just a Tendermint BFT algorithm implemented, but without the P2P stuff. That might be interesting to you. And what we'll be working on, especially after launch, but before, I mean, we'll start soon, is start the specification for changes to ABCI to enable permissionless ICS. And I think that's a whole other topic, so I won't go into that. But if you're interested in permissionless ICS, and what it takes for a validator to validate multiple blockchains. There's going to be a need for ABCI changes, and we'll be coming out with a spec for that as well. Can you scroll down, please? Okay, that's it. So contribute to Gno.land, proof of contribution. It's not proof of stake. What we're going to do instead is we'll have a token, right? Gno.land is going to have a token, GNOT for fees. But it's going. Gno.land itself will be operated by a DAO with members who have contributed to the chain, and membership is not going to be transferable. It's going to be about making sure the people who vote and control the chain are the ones who best understand it, as well as have contributed to it. So this is a really good time to start contributing and become a member. Work towards becoming a member, because you will have a voice in what Gno.land becomes. Right? And we'll be launching later this year. Here's the URL for this talk or the slides. I think that's good. That's it.
Questions?
Thanks. This is really cool. I feel like a lot of the frictions of CosmWASM development, they're like hidden ones, like manually typing stuff into JSON files, etc. They're just like completely resolved by having it on one VM environment. My question is, if you have multiple chains that deploy the Gno VM, then how would they sort of I guess how can we get to an end state where you could import something from another chain? Like, I'm assuming it could involve some adapter contracts, but like, is there maybe a more elegant way to do that?
Yeah, that's a good question. At first, what we'll do is we'll allow chains to import smart contracts from Gno.land. So Gno.land kind of serves as a repository like GitHub does. So you should be able to at least certainly import the P libraries, but I suppose R libraries too. We haven't thought that far yet. It's something to figure out. And then the next stage after that will be IBC calls from other chains to Gno.land, and or between chains for passing function calls and actually sending messages through IBC. I'm sure that's coming too. But we're not quite there yet. It's definitely an active field.
Awesome work. I kind of have a two-part question. One is there some sort of like metaphor analog to like the bank module, or is that like another contract itself? And then is there some sort of like schema or proto file in the context of like when we get into client cogen?
I'll start with the first question. Yeah, there is a wrapper for the bank module, so we do have the ability to create, basically implement, have native functions that are implemented in Go, and with that, the bank module is exposed. Yeah, and but there's a function like prevrealm. It basically gets the caller of a function, so that's a standard function that you will want to use. And we also have other safety mechanisms around the wrapper, so you can use it in a safe way. What was the second question?
The second part is that I'm guessing there's like a core part of Gno.land, and then there's the contracts. Would those interfaces be defined similarly? And in the context of like thinking about like client code gen, like parsing these out, would they all be protobufs or some sort of format that would be parsable to generate a client?
Sorry, I didn't understand. Is to get data out of the chain, or
to understand the interfaces to the contracts, and then the interfaces to like the core part of Gno.land, so you could generate like the analog to CosmWASM.
Well, we're not really using protobuf, but we have Amino too, which is the completed version, completely protobuf compatible version. One of the things I didn't mention is that we're currently working on Amino to serialize, so Proto 3 serializing everything in GNO, and also unmarshalling as well. So that'll help. But otherwise, I think what we want to do is keep everything Go. So the canonical representation will be Go interfaces and Go structures.
Hi. Thank you, by the way. I think it's really cool we can go all in on Go, and I'm just going to ask a few questions. Like, is it like the complete standard library of Go, and that's what it's going to currently support?
No, it won't be everything. If you need it, we can consider, supporting it. I imagine, but there's like regex. I don't think there would be any trouble with most libraries that you would want to import. One thing I didn't mention is we don't support Go routines yet. So channels and select statements are not supported yet, but they will be in the future. It's just at launch we don't see the need for it immediately. It's a lot more work, but we will have deterministic concurrency.
Also, yeah, thank you. And for like everything that you're importing, when you say that when you say it was sort of like a GitHub, I kind of imagined it was almost like an NPM library for smart contracts. Mm-hmm. Does that mean like the chain itself will be able to use imports similar to URLs to do, I guess, I don't know, like, I guess what I'm not understanding is how is the contract like sent to on-chain if it has to import potentially new libraries in order to execute?
New libraries from other chains?
Yes.
Yeah, we haven't figured that out yet. I imagine Gno.land, I don't know. I mean, if we want to make Gno.land a repository, I think maybe it makes sense to not allow imports only one way, so outside perhaps. Maybe it makes sense to allow imports. It's just, yeah, there's a lot of questions to figure out about that. Like, how do you manage the difference between synchronous calls and the fact that you're going to have asynchronous calls across IBC? So we have to figure out all those things before you can import and mix contracts from other blockchains. But we don't know. Maybe you'll figure it out.
Cool.
As a language designer, have you found that LLM progress has changed any decisions you make? Like, I don't know, like have more verbose APIs, or I don't know, structured functions differently with acknowledgement that, or test differently with acknowledgement that these AI models that are trained will generate a lot of this code, or it's not really affected anything.
LLVM?
No, LLMs like ChatGPT or
Oh, sorry, I didn't understand the question. Can you?
Oh yeah, like have these LLMs like influenced your thinking for what's the future of language design? Like, if we imagine that a lot of our code is spat out by these GPT models, and then can we afford more verbose APIs, or does the future of languages look different with given this?
Well, I can definitely see ways to improve and add more features to the language to make it better suitable for smart contracts and easier. One of the things would be like, when you saw the AVL tree, you know how everything's kind of stored in an in-memory tree. The structure of the tree is also how it's Merkleized. So at the end of the transaction, it not only persists the state, it also computes a Merkle root. So if you want a binary tree, you have to use an in-memory binary tree for efficiency. So that's why we used the AVL tree. But I guess you can use a Patricia tree if you want. And there are questions about like how to handle the Merkleization and because there's this other detail about how if you have an object in memory that has multiple references to it, so its ref count is more than one, then there's a question of like, okay, where is that stored, right? Because you have to make sure all the references to it have the same hash. So what we do is we escape it and kind of put it in a separate place, like it's heap escaped. And maybe you want to do something different. Then you might want to use, what we might do is extend this language with Go tags to annotate those kinds of things. But otherwise, haven't thought too much about extending the language yet. I haven't thought much about AI and LLMs. I imagine, yeah, I mean, it's. I think for me, the language is about getting humans to interface with machines. So it's a human, it's machine facing too, but it's also for a human. So I think until AI can get smart enough to model our own selves better than we can, I imagine we might be better at coming up with language. But I'd be surprised. I've been surprised with AI too. So who knows what'll happen.
Thanks. Yeah, I was just curious if it changed your thinking on it. Design. Another question is there anything like TinyGo, like TinyGno? Because this has been important with stuff like SP1 or like RISC-0. We're trying to like zero knowledge prove these things by take Go, compile to LLVM, and then like RISC-0 or RISC-V to ZK prove. But a problem they ran into is like they need kind of better embedded interfaces. Like remove the garbage collector, for instance. Is there like, have you thought much about configuration options for this, or it's like that's too far out?
Seems a bit far out. Yeah, we do want, I do want the Gno VM to be sort of this canonical implementation from which we can use processing to derive other kinds of machines. Like maybe take out all the things that have to do with Merkleization and persistence because you don't need it, or opcode counting because you don't need it, or even maybe optimization. But I haven't thought that far yet.
We can get it all, everything in one file. It's a lot of very pleasant overhead to remove. Yeah, just a single click, upload a smart contract, and you can interface with any smart contract that already exists, I think. Yeah, it's pretty nice. Thank you.
Yeah. So the entire thing in one file is super cool. But it feels like you could like do the same kind of thing with Rust, and then still like use some of the Rust, like the way memory works in Rust, and not have to like do the garbage collector for Go. So why did you actually choose for Go?
Well, I don't know how you would do it in Rust. I mean, like, for example, the way this thing works, while you're making any modification, anytime you change the field of a structure or anything at all, it's keeping track of in the machine, in the stack somewhere it's keeping track of everything you've ever touched and modified. And then at the end of a function, by the way, you can support nested recursive functions, kind of like SQL transactions, and then you can have like nested transactions. But my point is, at the end of a transaction boundary of a function call, it then condenses all the changes and then commits those to the storage. I don't know how you would do that in Rust unless you modify the Rust compiler itself, and that seems like a lot of work. And also, if you look at when I look at the success of JavaScript and how it gained so much adoption, it was the ease of use, right? It's the simplicity of the language that made it popular, and I think the same will probably hold true for smart contracts. At least this is type checked, so it's better. But I think simplicity goes a long way. I mean, if JavaScript had to have like, it didn't have a garbage collector and you had to do manual memory management, I think things would go a lot slower. Innovation would have been a lot slower. And I'm sure that other VMs will support different languages and be completely different, but at least there's one for Go and there will be a niche for it.
Thanks.
Hey, thanks for the talk. Just a follow-up question for when you explained how you have all these imports of smart contracts. I didn't understand yet, like, is there a smart contract verification that's off-chain? So when I want to import any smart contract that another developer put on-chain, like, where is that stored, and how do you envision maybe like a verification similar to ABIs on the EVM, on Ethereum happening?
Yeah,
on the practical way, how do you envision that?
Yeah, when you upload a smart contract to the chain, before it actually gets stored, it will load the code of all the dependencies. And right now, we just piggyback on the Go type checker. We take the portion of the type checker and just use it as a library to make sure the whole thing makes sense. Yeah, it's actually piggybacking on Go's type checker.
Okay, cool, thanks.
Thank you. As a Go developer, really excited to follow the progress of this project. I noticed you demonstrated that the Gno VM was running in a browser using WASM. Does that mean that we're able to deploy the VM on any CosmWASM chain in the future?
Does it mean that the Gno VM will be supported in WASM chains in the future?
Yeah.
Yeah, I suppose you can. Yeah, you could probably upload the whole VM into a CosmWASM chain for sure.
Interesting. That's cool. If you have the time, I was just wondering if you could elaborate a little bit more on the proof of contribution. In particular, like, is there like a rolling enrollment, or is there like a certain period in which you must contribute?
Yeah, that's a good question. This is one of the last pieces to get finalized, spec'd out, and implemented before we can launch the chain. We have, there's several ideas, but I think it looks like what we want is a tier membership system. So there are multiple tiers. Maybe what we'll have is the highest tier maybe has like 50% of the voting power, and all the other tiers are have the rest. So it's like geometric. I think what we want, we want the intelligence of we call it GovDAO, of the members and the voting system, the GovDAO system itself, to represent the most intelligence of, to keep the chain, keep the vision true, and not have too many diverging directions. So we don't want membership to be transferable, things like that. But now is literally when we're about to spec this out and finalize it. So it's a good time to get involved in figuring that out. Some other things we have in mind are maybe there's that there will be sort of an application process for membership. So you do your work and you kind of create a portfolio resume, and an admissions DAO, kind of like a university system, will evaluate your mission and then put you in the bottom two tiers perhaps, and then you can work yourself up from there.
Thank you.
Any more questions? All right. Thank you, Jae.
Thank you.
All right. And with that, we are finished with our first inaugural DEVMOS. So thank you all for coming. Big thank you to all the speakers. Rolando, our AV guy, who's been working us through all of our hiccups all day. I want a big shout out to Kristen, Kelsey, and David from the Osmosis team for sort of organizing and making this vision come to reality. And big thank you to, once again, all of you for coming. We have, after this, there is a Stargaze hosted after party. I think it's already begun because we went a little late today. But please join us there. And this month we have 3 birthdays, which are Jay, Jim, and Moon. So we have cupcakes out in the lobby area. So please enjoy the cupcakes, and thank you all for coming.